Now we take a look at integrals of vector valued functions. So let's suppose I've got this vector valued function. Let's suppose I've got, let's say sine ti plus, let's say t squared j plus just e to the 4tk. Suppose we've got this, whoops, for parentheses, dt. How do we deal with that? Well, remember, you think of these vector valued functions as a package of functions. And here you've got one integral, but really you're needing to integrate three things: the sine t function, the t squared function, the e to the 4t function. So let's do that. Here we've got negative cosine ti. Okay. Then we've got 1/3 t cubed j, and then 1/4 e to the 4t k. Now, remember, we're not done there. We've got to add a constant. So we need to add a constant. And this constant is not a number, it's a vector. So it's a little bit different here. So you have to remember that. And in fact, let's suppose that this vector is equal to C1, C2, and C3. So let's just suppose that. In other words, there's an x component, a y component, and a z component to this constant. Now there you have it. Now, you could write this a little different. You could write this as negative cosine t plus C1 plus 1/3 t cubed plus C2 j, and then of course 1/4 e to the 4t plus C3 k. You could do that if you wanted, but there's no need. There's just different ways that you could write it. Now, let's suppose that we're given an initial condition. So we integrated this vector, and let's suppose that we're told that r of 0 is equal to this vector, 3, 1, 5. Let's suppose we're given this bit of information. Well, remember, whenever something like this happens, whenever you integrate and then you're given an initial condition, you can use that initial condition to solve for the constant. So let's see how that would go here. We know that r of 0 is 315. So let's see how that affects the I component here. Well, we've got negative cosine 0 plus C1, that equals 3. Now, cosine of 0 is 1, so we have negative 1 plus C1 equals 3. So now we have our constant C1 is equal to 4. Now let's do the same thing for the j component here. We've got 1/3 0 cubed plus C2 equals 1. Well, this is easy. C2 is equal to 1. And then finally, we've got the k component here, and we've got 1/4 e to the 0 plus C3 is equal to 5. That means that here we've got 1/4 plus C3 is equal to 5. And that means that C3 is equal to 5 minus 1/4. And I believe that would be 19/4. Okay. Now, let's put it all together and see what the final answer is here. So if we were going to, let's put this in our vector. So we've got negative cosine t plus 4. Okay, that's the first part. Then we've got 1/3 t cubed plus c2. There you go. That's 1. See, c2 is 1. And then finally, at the end here, we've got 1/4 e to the 4t. Whoops. 1/4 e to the 4t plus 19/4. And there's our final result of our integration. Okay, so once again, you're just looking up on these vector valued functions as this package of functions. Now you could also have definite integrals. So you could have an integral like this. Let's suppose we're going to go from 0 to 1, just for simplicity here. And we have 2t plus, let's say t squared. Actually, what am I doing? This is I plus t squared j. And I'll do just 2 for simplicity here. And you can see how it would work with 3 variables or 3 components. So we get the antiderivative, which in this case is going to be t squared I plus 1/3 t cubed j, and we're going from 0 to 1. So it's just what you would think. You have 1I plus 1/3 j minus 0. And there you have it. There's your vector. Or you could look upon it this way as 1/3. But there is your vector valued, well, your definite integral after you've integrated. And this is a very simple example. You can see the complexity of this would depend on the type of function that you're working with. Here we just had very simple ones, 2t, t squared. Those are easy.